Hi student, how are you? Hope you are fine, good and great. Your teacher Ziaul Haq. Now we are going to know about the centripetal acceleration, which is also the part of the circular motion chapter. Let's see what is centripetal acceleration. Sorry, centripetal force. In this, like we have different types of forces. You know that normal force, contact forces, gravitational forces. So this is also types of force which is called centripetal force. And centripetal force, when the object is in the circular path, cover the circular path, so there is something on the object to keep the object in this circular path. So this force to keep this object in a circular path, this is called centripetal acceleration. Let's see the definition of the centripetal acceleration. Okay, centripetal force, this force keep the object moving in a circle with a constant speed. Like let's suppose this object is moving in the circle, so why this object, like at every point this object try to leave this circular path and move or in one direction, like go outside, but there is something to keep the object in this circular path. So this something is called what? Centripetal force, that not do not allow the object to move outside from the circular track. Okay, this is called centripetal force. It is directed toward the center of the circle, and remember this is also same like the centripetal acceleration. Usually, like if we tight a ball with the help of some string, and if we rotate this ball, so if I increase the speed of the ball, so this ball is also increase their speed, and if we decrease, so the speed of the ball is also decrease. So it is directed toward the center, mean it is controlled from the center, their motion is controlled from the circle, center of the circle. Okay, centripetal force is equal to m is equal to m time F is equal to m time AC. This is denoted the centripetal acceleration, or we can also write, we know that AC centripetal acceleration is equal to v square over r. So m is here, so instead of AC we can also use this one, v square over r, or we know that AC is equal to omega square time r. You can also use this formula m, or instead of this value we can also use this one, omega square into r. So this is called centripetal force, like which is denoted by CF. We can use any one of this formula according to the situation. Okay, let's see, we are trying to solve the example of the centripetal force. Here they ask the question like, a mass of 1.5 kilogram is attached to a string 50 centimeter long. It swing a horizontal circle with a speed of 2 meter per second. Okay, one thing remember, like if we tied a ball with some string, like if I want to rotate this one in a circle like this one, so there is some tangent force is produced between the ball and the this string. So in the next part they want to find the tangent force, and this tangent force is also called centripetal force. This is equal to centripetal force. Okay, let's see, find the what is given. Mass is equal to 1.5 kilogram. String, mean the radius is equal to 50 centimeter, which is equal to 0.5 meter. Next one, speed v is also given, v is equal to 2 meter per second. Okay, first we will use first we are going to find the centripetal acceleration, which is equal to v square divided by r, or use this two value, 2 meter per second whole square divided by r is equal to 0.5, which is equal to 4 meter square into second square divided by 0.5 meter. So this will be cancelled with this. So if we divide the 4 divided by 0.5, so now this is equal to 8 meter per second square. So this is the acceleration. If we divide 4 divided by 0.5, this is equal to 8 meter per second. Now the next part, B part, they want the tangent force, and tangent force now is equal to centripetal force, which is equal to M time AC. Like we can also use this formula, we can use the other formula as well. Now shortly we will use this formula. Okay, M is 1.5 kilogram and acceleration is 8 meter per second square, and kilogram time meter per second square, kilogram like mass time acceleration is equal to Newton. So if we multiplied this one, so this will be equal to 12 Newton. Centripetal force or tangent force will be equal to 12 Newton. Okay, thank you so much, dear student. Inshallah, in next video we are going to solve some other examples which is also related to the centripetal force or centripetal with a different point to derive some formula. Just staying with us, just keep watching our video. Thank you so much. If you have any kind of question, you can ask through any your comment. Thank you so much for stay with us.